Hello, welcome. Today we're going to discuss instructional design principles. First of all, let's talk a little bit about Mayer and Fiorelli. They discuss extraneous overload. That means that the learner's capacity is exceeded, their cognitive capacity. The cognitive capacity is the total amount of cognitive processing the learner's working memory can handle at any one time. Extraneous cognitive load is caused by poor instructional design. For example, too much extraneous information, poor instructional design layout, and poor implementation of that design. Today we're going to discuss 3 principles to help us reduce that extraneous cognitive load: spatial contiguity, coherence, and signaling. Let's take a look at spatial contiguity. This principle states that the bullet point and the illustration are on the same slide. The information is close to one another. We want to reduce the learner's need to scan back and forth between words and pictures. For example, on this slide, you can see that the apple pie, the picture, and the apple pie, the paragraph and description are right next to one another. The learner doesn't have to look around for that picture on another page. Why does spatial contiguity work? Well, this principle helps learners find relevant information. They focus their attention and their direction. Extraneous overload is caused by poor instructional design, in particular layout. This can be avoided by using spatial contiguity, according to Mayer and Fiorelli. The cognitive theory of multimedia learning states that learners use their limited cognitive capacity for processing what is essential rather than wasting it on the extraneous information. So let's look at another example. Here we have a formula, and right next to it in a box, easy to find, is where each variable is explained. That helps the learner. They don't have to search for anything. They're placed close together. Coherence principle, our second principle, states that we should eliminate extraneous material. You know, many of us are guilty of this when we're teaching. We go off on tangents, tell really great stories or cool facts that aren't related. We want to stick to the essentials. Here's an example. We have a paragraph on the guitars and then a picture here. Well, at the bottom of the paragraph, if you look at those last couple sentences, they're actually not really related to the subject matter at hand when we're teaching someone the basics. The essentials state we should eliminate that. And this picture of Jimmy, it's a great picture, but it's not essential, so we should eliminate that as well. So why does the coherence principle work? Well, because less is more, according to Mayer and Fiorelli. Learners benefit when they can focus on essential material rather than processing both essential and extraneous info. The cognitive theory of multimedia learning states that you do not want to overload limited processing capacity in our working memory. Extraneous overload is when there's too much extraneous information. It's caused by overly detailed information and materials or poor instructional design. And you can avoid this using coherence. So let's look at another example. Here on the guitars, the paragraph has been shortened, as well as now the picture is essential. It shows the 3 different types of guitars today. So let's move on to our signaling principle. According to Van Gogh, we want to highlight the organization of material. We want to bring the learner's attention to relevant elements in the material, and we want to highlight relationships between these elements. Without proper design, unimportant features can grab their attention and distract them from learning. For example, we have this football play up here with a little bit of information saying something about the quarterback. Well, if you're not familiar with the different symbols on a football play, then it doesn't really make a lot of sense. So with a little bit of signaling, we draw attention to the quarterback, and then the highlighted box also draws the learner in to see the relationship with the diagram. Why does signaling work? Well, signaling works because extraneous overload is caused when there's too much extraneous information. It's caused by overly detailed material or poor instructional design, and it can be avoided using signaling. Signaling helps us use our limited working memory capacity. It helps us to select, organize, and integrate this information. The cues will emphasize our relationship between elements in the text and pictures. According to Mayer and Fiorella, cognitive theory of multimedia learning explains that we want to focus more on processing the essential material in working memory and less on the extraneous material, and less on trying to sort everything out. Here's another example. Here is an equation. It's pretty decent. The variables are explained right next to it. However, let's make it better with signaling. Here we go. We've highlighted it. It draws the learner's eyes, and each of the variables are explained right next to it. So it makes it much clearer and easier for the learner to understand. They don't have to try to figure things out. Their attention is focused. So now we're going to look at an example from my workplace. The DAU guest network is what students can use when they bring their own device that has internet capability. But this information was jammed on 3 slides. And there was too much information. So the examples of the bad prior slides are with the pink header, and the gray header are the new current ones. I'm going to go through the lesson as if I was teaching it to a class. So today, first we're going to go through, I'm going to go through the slides. Here's a poor example, meaning that there's too much text, too much information. The bullets are there. It's not clear what to do. The learners will read through this as the instructor's talking. This one has illustrations. It has some signaling. However, again, there's a lot going on, and it's hard for the learners to know where to begin. And then we go back to the all-text bullets, and that's difficult for the learner, again, to pay attention to the instructor while reading through the slide. So let's take a look at the same material, but when it's taught using these principles to reduce extraneous load. Welcome. Today we're going to go through some steps to connect you to the DAU guest Wi-Fi network. It's available with your own device that you've brought with an internet interface. You can use your tablet, you can use your laptop, or you can use your cell phone. So let's go through the steps that you need to do in a moment. But first, what do you need to access? Well, this will allow you to access anything through our network, such as the iCatalog and other course resources. It also will allow you to access other government sites, commercial sites. We have .mil sites. But what's important to know is that when there are restricted .mil sites, that you are not going to be able to access these on our network. So now let's take a look at those steps you need to do to access things. First, you want to select the DAU guest. Then you want to go ahead and look at our password. Now here we go. With our password, you want to pay particular attention to the D being capitalized and the 3 instead of the E. When you have a choice of logins, choose the SSO student login. And then every student has a username and password, but most of us are used to using our CAC-enabled devices. So either you know your username and password, or you can retrieve it at this website, and we can do so on the first break. Once you have your username and password, we'll go ahead and enter the username, and then enter your password. And then you should be able to connect to our Wi-Fi on site. So that's an example of applying the principles. In summary, today we've discussed applying instructional design principles to reduce extraneous cognitive load. We went through three principles: spatial contiguity, keeping related words and pictures close to one another, coherence, removing the extraneous details, sticking to the essentials, and signaling, cueing the learner's attention. The DAU guest slides demonstrated how to implement these 3 principles. As a designer, be aware of the limitations of working memory and apply these principles to reduce the learner's extraneous cognitive load. Thank you for joining me today.